How's it going, everyone? Eulier Gonzalez here, looking at the NeetCode problem solution as a way to now look at how can we use now this data structure and algorithm to solve common real-life problems by recognizing is the pattern when it comes to actually giving a particular problem. What is the proper data structure and algorithm that we must follow as a way to actually come up with a solution for that? Using is the latest ECMAScript features. So, uh, the whole point of this series of videos is to record this learning process as well as look at what are the most common exercises that we need to do as a way to solve these problems, and when we need to find is and when we're in an interview we can actually identify that issue, that problems because we already practiced that with some similar problems, and now we can replicate that to solve that issue. So that's the entire reason of this is developing is this pattern recognition when it comes to solve real life problems with this particular tool, the data structure and algorithm. Okay, um, so far our methodology here is doing this in the 45 minutes. We're in the first five, but in the first 20 minutes we're gonna take a look now at the quick recap of what we have done so far. This 45 minutes is split in the first 10 minutes is to describe all the things that we have learned so far, as describing is the several problems that we have solved, and what are the value proposition of each one of them, the reflection upon that. Then I'm going to dedicate 29 minutes to look at this new particular problem, and then if we couldn't, or if I couldn't come up with some solutions, okay, so now it's time to look at the solution per se as a way to develop now this sense of solving these problems, recognizing these patterns by using this data structure and algorithm. So, as a way to now describe what we have done so far, uh, so first we'll look at how can we now identify a collection of values if there are duplicates. In JavaScript, this is something very, very trivial and simple. By using is the set, you can actually do that. The other is validate is there is a valid anagram, so giving it this particular word, see if they are the same, okay? And this is as a way to now see how you can start working with strings and also using some of the sorting methods or using the built-in sorting methods, okay? In this case with JavaScript, we use the built-in sorted method provide us from arrays, okay? And how now the sort methods is sorting our elements is per values, all right? So that so far so good. And yes, I mentioned here, and also how you can now start to work with strings, and when it comes to actually compare that string, how the comparison is using is a UTF-16 character set, okay? And then you will. The whole point of this is to work how you can transform from one primitive to another, or from one data structure to another data structure, from a string to a data to an array. Okay. So we also look at the two sum here, which is now this is where you started to work with hashes and data structure, or hashes and collections, as a way to see what is the thing that you can represent inside of your data structure. So the whole point of this is to look at the representation in your data structure, what this data structure can represent. And I think this is quite interesting, quite beautiful, by the way. Totally. Because now in this particular problem, we look at as we the entire problem was to see what is the it only exists one solution here. Okay. Yeah, that's right. It only exists one solution. Mm-hmm. Mm-hmm. Okay. Okay. All right. It only exists one solution, and that is find what is the number of elements. Yeah, find what is the index, giving a collection of numbers that when you add them, it match two targets. So here we're using is now and a hash as a way to if we don't have that element down, if we for example so we have our collection, we have our hash map, and in our hash map we're gonna say, hey, is this number is this number that we're iterating through is this array collection at that nth positions. If that number minus the target, do we have a store in our collections or in our hash in this case? If we don't, so let me add this value. And I'm going to add this with the key as the number and the value as the index. So this is the first step of how you can now represent things along the way. Okay, so far so good. Because now, as you iterate through all of the elements in the collections, if you find one of them that when you get that value and subtract by its target, it gives you something, a number that you already have in your table or in your hash map. Now the only thing you want to do is to provide now the index of that, the index at that element and the index at the so this is a way of how you can now provide is the complement values, so the two sum. Then we look at the group anagrams, which is another good exercise, because this it's a now it is time for us to work is with the collections of streams or collections of words, right? And see how you can group them based on their anagrams. So this actually it was quite similar to the two sum and the valid anagram, just that as we look at that elements, we sort them, we store that sorted in our hash as a key, and then our value will be is now a collections of all of the words that actually match that. Okay, which means that anytime we're going to iterate through all of this list of elements, okay, we're gonna sort them, we're gonna compare them with our hash. If that exists, I'm going to now add this anagram or this value here and do that so on and so forth. So this is great because this again this is an introduction of how you can now use this data structure, hash, and collection arrays as a way to represent something. And this is what the epitome of how you can represent and how you let's see if you truly know how you can represent your data here. Okay, because the top k frequent elements, this is something that you're gonna see a lot of the time, but a lot of the time over there. Yeah, this is something that you're gonna see a lot. A lot of the time here, the top k frequent elements here, especially if you want to know is what is the most frequent elements that a person buy in the last 1 week. Or for example, this is also useful for e-commerce, for metrics, for analytics, for anything related to the information, right? Is that how many users actually are looking at this specific page, you know? How many of them come from, let's say, the US, all right? So the top k frequent element. And this is an algorithm that the whole point of this is to say, because now you have now this collection of elements, you want to know which one of them are the most frequent, giving a k target, okay? And the whole point of this is to first, let's going to iterate through all of these elements as a way to now store is the number of occurrence in this on a hash map, okay? And then we're going to create now another collection, an array, okay? That'll be is the same length as the giving element that we receive, okay? As a way to, anytime we are iterating from the input from this collection that we're receiving as identifier is the top k most frequent value, we're going to, in this new array, each one of those index will represent is the number of occurrence, and their value will represent is an array of numbers. And that's exactly what we did here, right? In our case, we represent that is using a set, okay, as a way to only store is unique values. We don't care about repeated values if you find them. And when it comes now to extract that, because now we have is our hash map with the number of occurrence, and this new array or this bucket, okay, this array that now is containing all of the different elements, that contains all of the different, that each one of the index represent is the number of occurrence, and the value represents all of those numbers that match that occurrence. Okay, I know I'm quite redundant here. The thing here is to be very clear. So now you're going to sort them, okay, by their values, or instead of actually sort them, because now you got this array that is going to be added per position, and you want to know is the most frequent. So the only thing that you need to do is to actually reverse that. So we reverse that array, where now we're gonna have is the most frequent here, and we're gonna get is that substring or that sub element here, and that was quite interesting. So we're gonna get is this substring here, okay, which is something here. We're gonna get the we're gonna get is the substring there, and then I want you to now slice that, which means that give me a portion of this array that's starting from 0 to the k position, and that is the most k frequent element. This is very, very interesting and very beautiful exercise, because anytime you want to know is the most k frequent elements on something, this is what you gotta do. Then I look at the string encode and decode, and the TLDR of this is that now we're able is to see how we can now work with strings and store some data as we move on in the array. And exactly here is that how we're going to now is working with indexes as a way to move on to the as a way to move on as a way to move on, as a way to offset, well, as a way to move on, as a way to move up from different position here, or as a way to move up through the entire string, okay? And how can we do that? As a way to move through different string, as a way to see how we can now move, as a way to, there are a couple of things here with this string and decode. It is like, now see how you can not only store some information as in on a string as a way to represent something. In our case, we're storing is the number of we're storing is the number of the length of that word followed by a separator, okay, and then we're gonna extract that word and then decode that, which means is that adding to an array of elements. But the thing here is that as a way to do this, we're now going to use some index or pointers as we move, as a way to keep track where we are, at which position we are in this string, as a way to now extract is the data from this. One way to think of this is that you can, is this index will act as some sort of guards or some sort of some sort of guard, some sort of bouncer, okay, like the at the club. Okay, you gotta have this bouncer at the club here, okay, and the point of this is to see how you can now, as you started to work with each one of those specific elements. So what you work is with, as you work with this index, is that now how you can actually move through the entire collections, okay, as a way to now do something about it. In our case, extract some data. So working with this, okay, anytime when you need to add some additional information, when you need to know is the position of an element in a string, it is something helpful to use now pointers as a way to move around here, right? And I think that's quite beautiful, because now this is starting to develop this new sense when it comes to solve the next set of problems. So the TLDR with string and decode is that if you're gonna work with strings, okay, now how useful is to actually use is index as a way to move on across the entire strings to do something in particular, okay. That's one of the useful thing of this. All right, so in today's video, we are going to look is at NeetCode problem solution. There you got it. That's right. Yep. Okie dokie. Is this one? We want to look at now at this product of array except self. This was quite fucked up, bro. Think how you can efficiently utilize prefix and suffix products to calculate the product of all elements except self for each index. Can you pre-compute the prefix and suffix products in linear time to avoid redundant calculation? One of the things they're telling here is this, is that giving an integer array of number, return an array answer such as the answer in that position is equal to the product of all the elements of num except num1, num in that position. So the product of any prefix or suffix of nums is guaranteed to fit into 32-bit integer. And you must write an algorithm that runs in on time without using the division operator. Because if you're going to do that, for example, if you want to know is the product of array except self, you can now take each one of those elements, okay, and then you can divide that amount for this, because at the end of the day we want is to now calculate is the product of all the element except the element itself, okay. So for example, in this position we want to calculate is, we want to compute is a 2 times 3, which is 6, 6 times 4, which is 24. That's right. In the next position, we want now is to compute is the previous elements. 1 times 3, which is 3, and 3 times 4, which is 12, and now add this. The similar for the third position. We want to say now, hey, 1 times 2, I want to now compute this, which is 2, and then skip this element, move on to the next one, which is now you store that previous computation for that, and then you're going to multiply that by 4. All right. And similar for this position, where here you say it's like, well, what if the first element, which is 1 times 2, is 2, and 2 times, and the outcome of this will be is now 3 times 2 times 3 is 6, and that'll be all, right? So as you can see here, there are several solutions that you can use this, right? You can use this the iterative approach without space optimization, okay, and easy to understand first. All right, product of array except self, prefix and suffix products as well, which is basically is now is calculate the product of elements to the left of each element, exactly at that position. Calculate those at the length of that position, and then calculate is the product of the elements of the right of that position, okay, and then now construct is the answer for that, which is pretty much what we have now. This is not our intention here. The intention is to have is now calculated is the left and the right, all of this previous computation, okay, and the point of this is to then we're gonna store our answers in this, right? But because but because after all, because after all we want is to now is to compute all of the elements on the left and then all the elements of the right. One way to do this is by saying, well, initially, okay, one way to do that, and it is interesting because a lot of people actually now submit their, which is I think is quite good.
हाय एवरीवन, इस वीडियो में हम सॉल्व करेंगे प्रोडक्ट आना है कि जिसमें मतलब हमें इस एलिमेंट को छोड़ के और जो एलिमेंट है उनका
I truly love it. I truly love it. So we have now how we can solve this, right? By having is all of the prefix. We have a prefix, okay, and then also we have a postfix or a suffix, okay, and then we're going to somehow is find a way to actually compute that previous, okay, and then compute is those that are in the right. The question is that how can we now is compute that? Because again, this is one particular way of doing this. All right. Exactly. It's like how we going to compute that, because even though they give us a hint here, description here, exactly, they give us a hint. Think how you can efficiently utilize prefix and suffix products to calculate the product of an element of all elements except self for each index. That's quite interesting. That's quite interesting. And it has to be is on ON, okay, and it has to be in ON. So one way we can do that is to um, mhm. So one way we can do that is to store all of the elements, store all of the numbers in our hash, okay, and they're going to be sorted by insertion order, okay. So since they're going to be ordered by insertion order in our hash, okay, then I want you to now iterate through this collection, okay. Mm-hmm. Okay. Okay. So in this hash, I'm going to store is now as the key is the index. Uh, mm-hmm. The key is the index, and the value is that value. Or we can also shift that to say, hey, we're gonna store is okay. In this hash, we can store is the key as the value, and the key as the value, and the value as the index. All right. So anytime we ask this, we say, hey, now this is the position that we want to exclude, that we don't want to actually calculate. You know. Um, so with that index here stored in our hash, what we can let me actually try to describe this a little bit. So the idea here is that the idea. Let's go to store the index. Okay. Yeah. Let's go. Let's go to store the index of our the index and the value in a map as key value. All right. Or in this case, let's go to store is the value and the index in a map as key value, okay, from the nums. Why is that? So okay, so why is that? Now we have is the index. The whole point of this is to the whole point of this is to the value in the index, the key map, is to as we now iterate through this element, okay, we would like to now iterate through this. So the whole point of this is that we want to iterate, okay, through. So we want to iterate through the map, okay, and now exclude, okay. So we want to iterate through the map, okay. So one way to do this, we have, okay, an object will represent is okay. Okay. There's another way that we can do this is by having is a hash, okay. 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 So in this hash we can have is the value, okay, and the computation. So this value computation, which will be the left or the right. Yeah, this value computation here. Okay. Where here we can say is that I want to now, in the first elements, I want you to now iterate through all of these other elements here, okay, and get me that value. So in this hash map, what it can say is to, at this position, at the first position, okay, this is now the value, okay, this is now all the value. At the second position, I want to now compute is the yeah, and at this position I want you to now compute all of these values except this one. And in this position I want you to compute all of the value except for this position. And the same for this. And at this position I want to compute all of this value except for that position. Okay. So one way to do this. Yeah, to calculate is a prefix. Think how you can efficiently utilize prefix and suffix products to calculate the product of all elements except self for each index. Exactly. Except self for each index. You can pre-compute the prefix and suffix products in linear time to avoid redundant calculation. Can you pre-compute the prefix and suffix products in linear time to avoid recalculations? Okay. So oh my God. All right. So yeah, the idea here is to see how you can now compute all of these numbers, except for that, and see if you can compute that in linear time. Okay. And so, if we want to compute this, the prefix and the suffix, okay. And if we have these collections of with this index, and the first position we want is to now compute is okay. At this position in this element we want to compute is now this, the 2, the 3, the 4, all right, and then store the value there. since we are now here we want to calculate is the product. Okay. Um, okay. So 1, 2, 3, and 4. So how you can compute is the prefix and the suffix. Mm, mm. So if we have now this collection, mhm, so we want to know is the product of all the arrays except that position. Okay, because we want to compute the prefix and the suffix. Okay. So how you can compute this in linear time? One way to do this is by to say, hey, at that position, okay. Mm-hmm. Okay. 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 Mm, can you solve the problems of O1 extra space complexity? The output array does not count as an extra space for space complexity analysis. Mm-hmm. So if we want to now exactly, if we want to now evaluate this prefix here, as I want to say, hey, this position. So in this position, we're going to compute this in the prefix array. We're going to compute this in this position. We're going to exclude this. We're going to now is compute it at 2 and 3 and 4. And then in the second position, we're going to compute is now the prefix. Okay. So first, at the initial position, the prefix will be is this one. And then the second position will have now a prefix of this. So the idea here is to calculate now the left and the right. Okay. So one way to actually solve this in linear time, okay, the thing is that we are going to iterate through all of these elements, right? And if we want to check that one, and I want to make this in linear time. Okay. Product array except self.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve product of array except itself. So this is another problem from the blind 75 list. As you can see, it's over here, product of array except self. So I'm going to be adding that video solution today. And we're getting one step closer to having every problem in this entire list filled out. So for this problem, we're given an input array of integers nums, and we want to return an output array for every single number that we're given, where for each value in the input array nums, we're basically multiplying every single number except that value and then returning that as the result. For example, in this example, you can see we're given 1, 2, 3, 4. So for example, for this value 1, we would want to return the multiplication, the product of every other value. So for these three values, the product would be 2 times 3 times 4. That's going to be 24. So for the first value in the output, we're going to put 24. Similarly, for the second value, we want to multiply every value in nums except for this value. So that's going to be 1 times 3 times 4. That's going to be 12. So the second value in the output array is going to be 12. Now the hard part about this problem is basically the restrictions that they give us. So we have to solve this problem in big O of n time, and we have to do it without using the division operator. It would be really easy if we could use the division operator, because what we could basically do is take the product of all of these values and then, and we know that would basically be 24. So if we wanted the first value, so if we wanted 24, we would take this total product and divide it by 1, right? That would give us 24 if we wanted what the second.
Exactly. And if we wanted the entire multiplication of it, we divide it by this value, and we're going to get is the second output.
Value would be, we would take the entire product, 24, which would be all of this, and then divide it by 2, which would give us 12, which would be over here, right? Because the division is basically taking the entire product of the entire thing without multiplying by this. Dividing this would do exactly.
So we're multiplying this.
Exactly that. Because divide it by 2, which would give us 12, which would be over here, right? Because the division is basically taking the entire product of the entire thing without multiplying by this.
So we are taking is, so the division is not taking out of that element for that.
Dividing this would do exactly that. But we are not allowed to use the division operator. So if we wanted the product of every value in here except the 3, one way we can break it down is basically get the product of every value before 3 in the input array and get the product of every value after 3 in the array, and then multiply these two values together, and then that's going to give us the value that we would want to put in this position in our result. So it would be helpful for us if we want to do that for every single value in the input array, if we basically just compute the prefix product for every single position in the input array, right? And then put it in a prefix array. And since we're also going to be wanting the product of values after, it would also be helpful if we computed the postfix product of every single position in the entire input array, right? And we can compute both of these in big O of n time. It's a pretty simple algorithm, right? We'd basically start at the first position. Okay, this is going to be 1. So if we're adding this value, we're just going to take the previous value and multiply it by 2. So this is going to be 2. Similarly, we're going to take 2, multiply it by 3. We're going to get 6 here. 4, multiply it by 6. We're going to get 24 here.
So the idea here is to actually, by iterating, to have all of the prefix. Okay.
And for postfix, we're basically going to do the exact same thing and do it in reverse order. So here we would get 4. Here we would get 3 times 4. Here we would get 2 times.
So the idea here is to not having all of these computations in one way in prefix, and then getting all of the computations in the reverse order in postfix.
12, and then here we just get 1 times 24, which is just going to still be 24. Now for every single values, for example 1, we would want the prefix of every value before it. Now since there are no values before it, we can just say, okay, the prefix for that is just going to be a default value of 1 to keep it neutral. And so we'd also want the postfix of every value that comes after it. We can get that in the position to the right of 1. So we'd want to multiply those together. So 1 times 24. So in the output, for this, we would get 24. That makes sense because if you multiply all these together, except for this one, we do get 24. And then we just repeat the exact same process for every value. So over here, we'd want the prefix of the values that come before it, and we want the postfix of the values that come after it. So 1 times 12 is just going to be 12. That's going to be the output. Again, repeat the same thing for here. The prefix is 2, postfix is 4. We're going to get 8 as the output. That makes sense. If you take 24, if you take every value in here, multiply it except for 3, we do get 8. And similarly for this 4, we'd want the prefix 6 and the postfix, there are no, so we just assume that there's a 1 over here. So 6 times 1, this would be the output. So this is a very valid solution. This is a big O of n time solution. We're not.
This is a big O n time solution. And also it's a big O n. Yeah, this is a big O n time solution, and also this is a, but also is a big N space
using any division operator. But the downside is this is also big O of n memory, but we can actually use this idea because what they tell us is the output array does not count as extra memory. So we actually don't need these prefix and postfix arrays, because we can compute these, and we can compute these prefixes and postfixes and then store them in our output array, and that is going to end up making things easier for us because we're not going to have to use this extra postfix prefix memory. So what we're going to do is we're going to do 2 passes on our input array nums. First, we're going to start at the beginning and then go all the way to the end, basically computing every single prefix for the input array and then storing the prefix. So for example, the prefix of this is going
so multiplying all the prefix
to be stored over here, right? Because that prefix is needed to compute the result for this position. And so at that point, what we're going to say is every prefix is going to be in the output. Basically, the prefix over here is going to be stored in the second position. The prefix over here is going to be stored here. The prefix from this is going to be stored here. And remember how for the first position, there is no prefix, so we're going to put a default value of 1 over here. And then after that, we're going to do a pass going from the end to the beginning, computing every postfix. So for example, this postfix, and then in the result, we're already going to have the prefix stored over here. This prefix, right, the first 2 values is going to be stored over here. So what we're going to do is we're going to take this prefix and multiply it by whatever is in this position. That's what's going to give us the result that we want for this position. So let's start off. So far the prefix that we're going to be at is just going to be the default value of 1. So we're going to put a 1 over here. Then we're going to multiply it by what value comes over here. 1 times 1 is going to stay 1. So we're going to leave our prefix as it is. Now we're going to be at the second position. So what we're going to do is take our prefix, which it basically tells us the prefix up until this point. We're going to take that and then put it in the output. So 1 is going to be here, and then we're going to take the value that we just reached, multiply it by the prefix. So now the prefix is going to be a 2. So now we're going to be at the third position. So what we're going to do is take our prefix up until this point and go ahead and put it in the output. So 2 is going to be placed in the output. Then we're going to take the 3 and then multiply it by 2. That's going to give us a 6 for the prefix so far. So at this point, we're going to take our prefix, 6. It tells us the prefix up until this point. So we're going to take it, put it in the output. 6 is going to be put in the last position. Then we're going to multiply 4 by 6, which is going to give us 24. But that value 24 is not going to be put anywhere because clearly we have run out of room to put it. So we don't need to store it in the output. So now we've visited every single value from the beginning to the end.
And once you do this, because now, okay, so once you do once you visit all of the elements here, and then you store it with the prefix, and then you store it with the prefix here. You know, the prefix here, this first position is 1, and the second position is the multiplication from the previous thing.
Computing the prefixes and then putting them in the output array. So now we're going to start at the end and go to the beginning and do the exact same thing, except we're going to be doing postfixes, which are basically starting from the end of the input array and computing the products. Once again, the postfix is initially going to be set to 1. So what we're going to do is take the 1, which tells us the postfix up until this point, basically an empty thing. And that makes sense because for this value 4, we would want the prefix of it as well as the postfix, but there is no postfix, so that's just going to be a 1. So we can take that 1, multiply it by 6. So 6 is going to stay the same, so that's going to be the result value for this position. But then we're going to take 4 and multiply it by the 1 in our postfix. So so our postfix is now going to be 4. So we visited this position. Now we're going to be at this second position. So we're going to take our postfix, which tells us the postfix up until this point, and then multiply it by
the elements in that
by the 2 that's in this position. So 4 times 2 is going to give us an 8 for the output value. Then we can take this value 3, multiply it by our 4, which is going to give us a 12. So now we visited this value. Now we're at the next value 2. So we're going to take our postfix up until this point, multiply it by the 1 that's here. So this is now going to be a 12. And we can also take the 2 and multiply it by 12, which is going to give us 24, which tells us the postfix up until this point, which is going to be useful for us because we know that if we want to get the product for this position, we're going to need that postfix. So we can take that postfix 24, multiply it by the 1 that's over here. So this is just going to be a 24 now. And that's the entire result. So we basically did the exact same thing that we did with our prefix and postfix arrays, but in this case we did it without using the extra memory, and we ended up arriving at the exact same result. So it was linear time complexity, big O of 1 memory complexity. Now let's jump into the code. So the first thing we're going to do is create a result output array. So this technically does not count as extra memory in the context of this problem. I'm just going to give each position an initial value of 1, and we want this to be the length of the input array, so we can multiply it by the length of nums. So first we're going to be doing the prefixes. So I am going to initialize prefix
in JavaScript. It's like it's not that easy, because at the end of the day you need to specify the fixed length for
as 1, and then we're going to go through every position in our input array. So for each position here,
now what you to now is calculate is the prefix by the value in that position, and then update the prefix giving that
in our result output array we're going to take that prefix and then just put it in that position I, right? And then after we've
initially
done that is when we're going to take the input array value nums of I and multiply
okay, and then at that position you're going to add the prefix, okay, and then in that position, I want you to now get that
multiply it by whatever the prefix happens to be. So prefix is just going to be multiplied by this value.
Completely, because now what you're doing is to say not only multiply that, but obey the
So that's how we're going to be computing the prefixes as we iterate through the input array num.
And this is not to compute is all of this in one line, in one go, right? So what you're doing is to, hey, in this position, in the position, okay, in this position we're gonna store is now the prefix, but now the prefix is whatever you have in that position followed by the initial prefix, and this is what you're going to compute all of this, and now you're gonna have is the result of the prefix.
And we're going to be storing the prefixes in the result output array. After we've done that, we're going to do the exact same thing with the postfix array. Well, almost the exact same thing. So we're going to start at the end of the input array and then go up until the beginning, and that's how you can do this in Python. And so in this case, the result of
the result now of our response is which is in that position, okay, is our post. Exactly, will be our postfix.
We're not just going to be simply storing the postfix value, because we know that would end up overwriting.
Yeah, we're going to overwriting is that. But here we is
in the result, whatever the prefix we stored was, what we're going to be doing with the postfix is we're going to be multiplying it by the value that's already in results, because that's simply multiplying the prefix and the postfix together. Once we've done that, we know we do have to continuously update the postfix. So with postfix, we're just going to multiply it.
So after you multiply that postfix, then you're going to multiply is the postfix at that position
by whatever value happens to be in
the numbers,
the input array nums. And once that is done, we're actually done with the entire problem. Then we can just return the output array result. So this is pretty much the most efficient way to solve this problem. As you can see, best memory complexity, best time complexity as well. So I hope this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon.
But the pattern here, okay, but the pattern here but the thing here is that product of array except self.
Just improve your problem-solving skills and you'll be able to pass all your coding interviews. Just solve some linked list questions over here and some tree questions over there, and then you'll be able to derive the edit distance algorithm yourself, just like this Soviet mathematician did in the 90s.
Just like the Soviet mathematician.
1960s. If that sounds ridiculous to you, it's because it is. Let me tell you a little secret. You're not supposed to figure it out yourself. Did you ever watch that episode of Naruto where the exam is intentionally designed to be so difficult that the only way to pass is to cheat? Well, that's the modern coding interview in a nutshell. Let me tell you what I mean. We all learned long multiplication as kids. We all memorized this algorithm. To get the product of these two numbers, first we take two. Have you noticed that some people are naturally better at LeetCode or just learn faster than others? Well, usually those people come from another highly technical background like math, and they probably already built a lot of problem-solving skills that can be applied to computer science. It makes sense why a mathematician would have an advantage over, say, a farmer, for example. So, what can you do to give yourself an advantage? Don't focus on extremes. If you try to memorize solutions for every single problem, which is not easy, by the way, you'll never be on a single problem and still won't be able. For a problem, you'll spend 10 hours on it, never look at the solution. For a problem, you'll spend 10 hours on a single problem and still won't be able to figure it out. In my opinion, there is an intersection between coding interviews. Memorize the core CS algorithm. A reasonable approach to coding interviews would be to first learn the core algorithms needed. It's fine to look at solutions. You're in the learning phase. Just like an ML model, you're taking in training data. After that, you should try to apply your knowledge. If you were able to derive the solution to all these problems by yourself, it would greatly improve your problem-solving skills. But that's obviously not realistic. But consider this. If you're trying to figure out the edit distance algorithm, you would have a much better chance of doing so if you first solved the longest common subsequence problem, because it has significant overlap. And
exactly, but okay.
Pretty soon. Thanks for watching.
That's great, and I get it, here because what we're doing here is not only is to look at how you can solve all of these particular problems and that kind of thing, right? It's also understand how you can use now these specific tools as a way to solve a specific problem. Yes. So because here the product of array accepts self. So one way to do that is to have this now prefix and postfix. Okay. So you don't want to compute this element at that position in the collection. So what you can do now is to say, let me now compute everything that is before that element, or the element of the left, all right, and then let me compute now all of the elements at the right, okay. And once I do that, once I compute, once I multiply them, I want you to now is also multiply them to as well. So because this particular solution is using the prefix and the postfix, okay, they say you must write an algorithm that runs in O(n) linear time without using the division operator. Why is that? Because as we now compute all of the single elements and we can divide that by that value, we're gonna get is the current value without that element. So we're gonna get, so if we take all of, so you have this giant piece, and what you say, hey, I want you to now is divide that by this. In other words, is that see how you can now take all of this completion and get me is the division based on this completion. In this case, it's 24. Now give me is the value once you divide that by 2. All right. So you're gonna get is 12 here, and 8 and 6 and so on and so forth. So with this particular mindset here, The idea for this product of an array self except self is to do something like this. So instead of actually storing is all of those arrays, okay, as the prefix and as the postfix, and even here they tell you is the hint to compute that. So one way to solve this is by calculating is all of the prefix in one run, which is I want you to now calculate the prefix, which is in this case is 1. Let's going to assume that is 1, multiplied by this, the first position, and that'll be now what you're going to store in this new in the output array at that position. And then you're gonna go into the next one and say, all right, now after I update the prefix, I'm going to now is with that prefix, which in this case is 1, now I'm going to is multiply by the next element, which is now what we're going to store in that new position at that array, okay, and I'm going to update the prefix here. So once I update the prefix, which is in this case is by the multiplication of this 2, which is now 2, then I'm going to go to the next element, all right, which is 6, and this is what I'm going to store now at the at that next and that current position, okay. I'm going to update the prefix here. So but the point of this is that once you multiply all of this in one way and then the other way around, okay, so once you multiply all of these elements like this and then you multiply back, then which means is that once you get is this element, holy moly, that's pretty wild, because here what we're saying is that it's going to reserve a space in memory for the result, which is an empty array. All right now is empty, but if you're working with Python, you must indicate is the length of this. So in our case this will be an array, okay, in which the length of this an empty array, okay, where that length will be is the same as the number array, okay. And after that you want now is to do something like this, where you want to first iterate with the prefix through that element collections, and here we're gonna say, hey, let me now define as a prefix, okay, which is 0, 1 initially, and I want to iterate through all of those elements, all right, in the value number of nums, okay. Since this is now an iterable, this is the reason why we can use this. Numbers are iterables. I'm assuming that numbers, because this is an array of number, this must be is the this must be is the entries, okay. So as a way to don't lose my mind, we can is actually doing is this, and when we run this, we're gonna get is all of this value now printed here as it is. Say, hey, function whose declared type neither undefined void must return a value. Okay, but in this case is let's going to return is the result. All right, that's right. So now you're not going to comply in terms of that, but the idea here is to actually look at that. And as you can see here, we are now able is to see is the key and the value. So Another thing is that question, do you need to do this for array of numbers? After all, they are arrays. And here I'm getting is the value by default, which is a great thing if that's what you're looking for. Okay, but since we wanted to also work is with our index, we want is the index followed by the value here. All right, so what we're gonna do is on this first iteration we want is to go through all of these elements here. Yeah, we want to go through all of these elements here. We're going to say, hey, the elements at that position, okay, the elements at that position, which is 1 initially, it'll be the prefix, okay, 1 is the prefix, and then we want is to now multiply is the prefix to whatever we have in that position, which is prefix multiplied by the result on that index. But it's not only the index, in fact it's the position at that is at the nums that we want to get that. Okay, and this is what we're going to store, okay, now in the result dot index. So this particular value is what we're going to store is in there. But look at what we're doing here. Here we're assigning is this, so at that position we're gonna have is that, okay, and then I want you to now take the prefix, okay. We also can is say let's going to update the prefix, okay, with the result at that index, okay. So assign this prefix to this, and then let's going to update the prefix here. Which is our new prefix, okay. And then that particular prefix will be is now what we have in that particular position, okay. And the result we're gonna store that is in that index. So in the next iteration we're gonna say, hey, on the first iteration we got 1, so the result of index is 1, okay, exactly is 1. Then we update is the prefix here to say is 1. All right, and now we're going to store is the result, and now we're going to store is the result and now we're going to now update is the result exactly, and then we're now going to is update is the, but in this case is something it oh my god, why? But in this case here in this result we're gonna store is the prefix, and then we're gonna update is the prefix. How do we update is the prefix? By in this case is multiply and assign that value to whatever we have now in our nums at that position, okay. Multiply what I get here in the initial time, which is 1, with that value at that position, which is 1, okay. and in the next iteration, which the result is now 1, okay, which is in this case exactly is 1. Now I already update is the prefix to be there, which it was the multiplication of the 1, and yeah, it was the multiplication of 1 by the number of that position, which is 1. Okay, so in the next iteration, we want to store now is that 1, that prefix at this position, at the 1 position, and then I'm going to now is to get the prefix, multiply by the element in that position, and that'll be my new prefix here, which is 2. That number 2 will be is now the next position. Okay, that 2 will be now the next position in the result, because that will be the prefix. Okay, and then I'm going to now take the 2, which is the prefix, multiply to the next value, which is in our case is 2 plus 2 times 2, it is 4, and that will be stored is on the next position on the results array, okay, which is 4, and that force will be is the prefix. Okay, now that 4 is something that we're going to now multiply is that with the elements in this position and update our prefix, which is 6, and we're gonna put that in the next position here. We're gonna put that in the next position here. Okay, and because we don't want is the last element, that's one of the reasons why we need to indicate that this result must be is the length of this num dot length. Result dot length will be is the nums dot length. Why is this? Because after all, we don't want is to get a different length from that, which means that we want is to discard any elements that we there. And then we're going to define now is the postfix, okay, as 1, where we're going to start now from the last element. Okay, yeah, from the last elements, where to actually start from the last elements from our nums entry, we can say is, well, I want you to now the index and the value start from the nums dot reverse. Okay, but of course this must be reverse, and then provide me is there is values. Okay, so now here, okay, so now here we're going to now compute these values in the reverse order. In other words, is that now we're going to say, hey, at this position on the result dot index, which is the last element, is from the end in this descending order. Okay, at that position, all right, I want you to now multiply that with the postfix that we get, Okay, and yeah, the posts that we get, and update that here. Post fix. All right, so initially, now that we already have this as 6, then what we're gonna do is to say, hey, the 6 here, we want to multiply that with 1, so that'll be the result at that position, okay, which is 1. And then we want to update the postfix here. If I exactly, and then I want to update is the postfix here by multiplying is that, and then assign that with the value in this num position. So in this case is, what is the postfix here? Well, the postfix value is that whatever you got is, in this case, is 1 times the position of that, which is 6, which is initially is 6. Okay, then you're going to move on to the next element here, and that is the result now here, it'll be is what you got in the at that position previous the postfix, which is 6 times the number of that position in your result, which is in this case I think is 3. Oh, because it's this. Yeah, because if I don't put this, he will add more elements to that. Yeah, I want you to count is from the last element.
The result
Yeah,
of the is in the at the end of the input array, and then go up until the beginning, and that's how you can do this in Python. And so in this case, the result of I, we're not just going to be simply storing the postfix value, because we know that would end up overwriting in the result whatever the prefix we stored was. What we're going to be doing with the postfix is we're going to be multiplying it by the value that's already in results, because that's simply multiplying the prefix and the postfix together. Once we've done that, we know we do have to continuously update the postfix. So with postfix,
yeah, but in our case, it's like, how do I reverse that in Javascript?
And so in this part, at the end of the input array, and then go up until the beginning, and that's how you can do this in Python.
but well, in my case it's like I want to go from the end, which is reverse, okay, which is reverse that. And both of these are iterating is into that.
Done with the entire problem, then we can just return the
Is because here exactly 4 3 2 1, which is good. Oh, I get it. Oh no, because it's we're working is with the index. That's what happened. Oh, okay. Exactly. Oh, okay. Exactly. Yeah, because okay, we're working is with the index, so we need to find a way to actually get that in. Okay, it's the problem is here. The problem is here. hmm The problem is here. It's because now we're working is with the index, and here we wanted to find somehow is to start from that, you know. So how you can now is okay as an array in MDN. So how you can now start is from the end, you know. How you can start from the end. How to start from the end in JavaScript array. Okay. Mm-hmm. Array from. Interesting. Yeah, the array like. Mm-hmm. Sequence generator. Okay, range. Start, stop, and step. Sequence generation function commonly refers to as range, enclosure, PHP, and etc. Counts range, start, stop, and step. Array from. You got is this. When you pass now this, generate numbers, range 0.1. Possess sequence generator. Oh, but I don't want to generate a sequence, my friend. If I want to start it from. Okay. How to start from the any JavaScript array. Do you have any built-in function? I mean, I can write my own. I don't have any problem with that. Exactly. Or how to start iterating an array from the end in JavaScript. Yeah, but don't you have exactly dot slice reverse for each item or for off loop? Yeah, but the problem is that we want is the index. The problem is that we want is the index. We want to work is with the last index. Yeah, because we want to work is with the last index. Is like no, because we want to work is with the last index. That's what happened. Yep. So here we need to go is with this. So instead of doing this, we're gonna say, hey, for that index that'll start at the nums dot length -1. We're going to is now iterate through or iterate until index is until iterate is less than 0. or equal to 0. Once it is 0, I don't want to get in here. Okay, and then the after through is that we're going to decrement this. So by doing is this, we are now starting is from the last element, and we're going to decrement that, which is now makes a lot of sense as a way to work with this. Oh, because it's index. Exactly. Exactly, from that position, okay, it's from that position is what I want to iterate through that. Oh, you're gonna do this, exactly, you're gonna do this is, as long as the index is greater than 0, exactly, you're gonna do that as long as the index is greater than 0, and then you're going to decrement that after you evaluate this block. Because this is start from 0 to that, exactly, it's -1. Exactly, it's -1. So because now here what we're saying is that we want is to iterate from the last position, and because a line contain is all the elements, and they count a 0 as 1, so we need to count it from -1 as a way to indicate that this is the address or this is the position in our collection. I want you to now do this until the index is equal to 0 or less. Okay, as long as the index is greater or equal to 0, you're going to do this. Okay, and then on each iteration, I want you to now decrement that. So this is the way of how you can now iterate through that, iterate in one direction from start to end, and then when you want to iterate from end to start, you do is this. Holy shit. the time complexity is linear time, exactly. And the memory complexity is constant time, exactly. Mm-hmm. An array of numbers, where here you say this will be a new array of the numbers dot length, or the nums dot length. Is number. Exactly. Holy moly. But this is as a way to now work is with, oh my god. This is as a way to work now is with this. This is as a way to now work with this. Day 5. Yeah, day 5 if product of an array except self. Product of an array except self. Product of an array except self. Reflections. Work with arrays, okay, which is something that even they mention here. Make 2 passes. Make 2 passes in order in order in order in order it's a make okay, it's make 2 pass work with array, exactly, work with arrays, work with array iteration from start to end to start. To validate Sudok. Okay. Okay. Okay, holy moly. Okay, it's because this is the challenge here. Okay. hmm Well, that'll be all for this video. Take care. Product array accepts self. Work with iteration and start and ends, and working with prefix and postfix. That'll be all for this video. Take care. Bye bye.